Okay, so that ends class for today. We'll start with dividing complex numbers next class. Given any complex number, a plus bi, the complex number a minus bi is called its what? Complex conjugate. Good. So a few facts here. The product of any complex number and its complex conjugate is a real number. So this means that when you multiply a complex number times its complex conjugate, then what we have using what method? FOIL. Good. We use FOIL here. So first, outside, inside, and last. You get a times a is a squared. Then you have a times a negative bi. When you multiply this times this, we get the minus abi. Then when you multiply your inside, you have bi times a. That gives you the abi. And then you multiply your last. Multiplying your last gives you this minus b squared times I squared. But we can see here that these are opposites, so they cancel out, right? And then we know that I squared is what? -1. Good. So this gives us here a squared minus b squared times -1. But when you're subtracting a negative, that becomes a positive, right? So that gives us a squared plus b squared, which is a real number because we assumed a and b were real. Okay, so that's important to remember. So the takeaway from these facts is to simplify a quotient of complex numbers, we multiply the numerator and denominator of the fraction by the complex conjugate of the denominator. Okay? A lot said here, but let's repeat it. Whenever you have a fraction that has a complex number in the denominator, to simplify that, you multiply both the numerator and denominator by its complex conjugate. Okay? That's what we'll have to do. Okay? So remember, you print your notes off and then you can just fill in the blank. That way you don't have to write everything down. Okay? That allows class time for other examples and questions. Questions here? Okay, so let's go through a few examples. So let's simplify the following expressions. Let's simplify the following expressions. Here, we have 1 plus 2i divided by 1 minus 2i. What do we need to multiply by to simplify this expression? Say it again. The complex conjugate. Good. Remember, if you need to send a text message, go out in the hallway to handle that. Okay. You have 1 plus 2i over 1 minus 2i. To simplify, what we need to do is multiply both the numerator and denominator by the complex conjugate, as you said, of the denominator. What's the complex conjugate of the denominator? Say aloud. 1 plus 2i. Very good. So we're going to multiply both the numerator and the denominator by 1 plus 2i. Notice that we did not change the problem because 1 plus 2i over 1 plus 2i is really 1. Right? So we're not changing the problem. We're just multiplying by 1 in a particular way. Okay? So let's multiply. So this is going to be 1 plus 2i times 1 plus 2i over 1 minus 2i times 1 plus 2i. Okay? And then we use our FOIL method to multiply in the numerator and the denominator. Doing so, we get 1 plus. Do you need me to write out the steps where we're multiplying specific terms, or do you want me to just write out the result? The result? Does anyone need to see the step in between? Yes? Okay. So we multiply the 1 times a 2i. That's what we get when we multiply your outside. Then your inside is going to be what I write here. So then we have plus 2i times 1. And then we have plus 2i times what? Multiplying our last. So 2i times what? 2i. Very good. And then we're going to divide that by what? Walk me through it. Talk loud. 1. Say it again.
1 minus 1 times 2i.
Are you doing your outside or your inside first?
First.
Say it again.
It's the first, right?
We did the first to get 1. And what are we doing next?
Outside.
Outside. So 1 times.
2i.
Good. So plus 1 times 2i. Then,
Inside.
good, your inside, which is
Negative 2i times 1.
times 1. And instead of writing negative 2i times 1, we're going to subtract 2i times 1. If you decide to say I'm going to multiply negative 2i times 1, just make sure you put plus in parentheses negative 2i times 1. Okay, both give you the same thing. And then we multiply our what? Last, good. And we get minus 2i times,
2i.
you got it. Good. And then we simplify. So we get 1 plus 2i plus 2i plus 4i squared all over 1 plus 2i minus 2i minus what?
2i squared.
2i squared?
4i squared.
Ah, 4i squared. Good. And so then we simplify. This becomes 1 plus what? 4i. Good, because we're combining like terms at this point. You combine those. So you get 1 plus 4i plus 4 times what?
Negative 1.
-1, good. Because I squared is -1. What happens in our denominator? On this side of the room, what happens in the denominator? We get 1, go ahead. What happens on this side of the room? Say it loud. The 2 i's cancel out, good. And then anyone, what do we get? 1 minus, what's our, 4 times -1, because I squared is equal to -1. Good. So then we simplify where possible. So this becomes 1 plus 4i minus 4 divided by 1, what's the rest? Plus 4, good. That simplifies to be 1 minus 4 is what? Good. So 1 minus 4 gives us this -3. Not yet. What else do we have in our numerator? Plus 4i, all divided by 5. Good. So then the only thing left that we can do, because we want to write this as a complex number, is -3 over 5 plus 4 over 5 times I. So another example, we have the quantity 2 plus 5i raised to the negative 1. So here you need to recall, remember if you need to send a message, go out in the hallway. Recall that this is something you need to remember prior to this class, so let me give it to you here as a refresher. X to the negative n can be rewritten as 1 over x to the n. So where we have this quantity to the negative 1, that means we can rewrite 1 over that quantity to the 1. So 2 plus 5i, this quantity to the negative 1, is the same thing as 1 over the quantity 2 plus 5i to the first power. And because that's to the first power, do we really need to write 1 as our exponent? No, we don't. Very good. So what we're going to do now is simplify this expression. So how do we simplify this expression? We have to multiply by the complex conjugate in the form of 1. Good. So we have 1 over 2 plus 5i times what? Speak loudly. 2 minus 5i. Why 2 minus 5i? Because it's the what? It's the complex conjugate. Good. So 2 minus 5i over?
2 minus 5i.
Good. And then we simplify. Would you like a minute to simplify? I'll give you a minute to simplify. Okay, so now that you've had time to work on it, you multiply your numerator times your numerator over your denominator times your denominator. This gives us what in our numerator? 2 minus 5i. Good. Make sure this is what we're working on now. 2 minus 5i. And then, remember, you have to multiply your first, then your outer, then your inner, and then your last. Okay, so that gives us 4 plus. Remember, you always have to say plus whatever you're multiplying. Or if you know it's going to be a negative, you go ahead and put you subtracting. Okay, either way. Plus 2 times what? 5i or? Negative 5i, good, because that's our outside. Then our inside is plus 2 times 5i, good. And then plus what?
5i
Times negative 5i, good. Speak louder, okay? I hear other people talking too, and that's good. Everybody can respond. I'm happy with that. So all of this is in our denominator, so let's make sure it looks like it's in our denominator. So this gives us 2 minus 5i divided by what? 4, go ahead. What is this? Minus 10i.
Plus 10i minus 25i squared.
Good, all of you. And then what happens?
You combine like terms, each other out.
Good.
So it would be 2 minus 5i over 4 minus 25i squared.
What can we do here?
Change the I squared to negative 1.
Good.
So then it'll cancel it out and make
It doesn't cancel out.
Well, it just makes it a positive.
So in our numerator we get?
2 minus 5i.
Good.
5i over 4 plus 25.
Very good.
And then you combine like terms. So it would be 2 minus 5i over 29.
Over 29. Good. And then what do we do?
It's 2 over 29.
Go ahead.
And then minus 5 over 29.
Minus 5 over 29i. Very good. What questions do you have? What questions do you have? Let's look at another example. Does everyone have this? Responses are great. Okay. So part C, we have 1 over I to the 27th. 1 over I to the 27th. Zoom in a little bit. We have 1 over I to the 27th. Now, this is a what in our denominator? It looks familiar. It's a power of I, right? Good. It's a power of I. So what we want to do is figure out what this power of I is first before we simplify. So to figure out, so on the side, different color for an aside, I to the 27th, we want to figure out what that's equal to. So remember, we have to take 27 and divide it by what?
4.
Good. 4 goes into 27 how many times? 6 times 4 is 24. Subtract, we get what? 3 is our remainder. So that means
It's 4n plus 3.
it has that form. It has the form I to the 4n plus 3. So this has the form, very good, I to the 4n plus 3. And I to the 4n plus 3 is the same as what? I to the third, good, which is negative I, good. So we get I to the 27th is negative I. That's helpful for us because whenever we want to simplify 1 over I to the 27th, we know that's the same thing as 1 over negative I. And because that's 1 over negative I, we then now know what to multiply by. We multiply by its complex conjugate, which is just what? I. Very good. It's I. So we multiply this 1 over negative I by I over I. And this gives us I over negative what? What's I times I? I times I is I squared. Good. And it's negative because we have that negative hanging out here. That negative comes over because of negative times a positive is a negative. But we know I squared is the same thing as what? Negative 1. So we have negative times negative 1. And what does that give us? I over positive 1. Good. Which is what? I. Very good. So that's our answer. That's our answer. Questions? Okay. So, a fact, we can now say, given a positive real number A, given a positive real number A, note that the square root of A is the positive real number whose square is A, and we can say that the square root of negative A is equal to I times the square root of A. Does this make sense? No? Okay, so remember, so on the side, remember that if we start out with the square root of negative A, that's the same thing as the square root of negative 1 times A. Are we good so far? Okay, so this is the square root of negative 1 times the square root of A. What's the square root of negative 1?
1.
No, it is not. Square root of negative 1 is? I. Good, it's I. We reviewed that, right?
Yes.
Okay. Remember when we defined an imaginary number, we said that I is equal to the square root of negative 1. So this becomes I times the square root of a. That's where this highlighted portion is coming from. So that's important to remember, that the square root of negative a is the same thing as I times the square root of a. Okay? So some things you need to recall from classes prior to this class. The square root of a times the square root of b is equal to the square root of a times b. A and b must be real numbers for this to be true. That's important. A and b must be real numbers for you to use these two. The square root of a times the square root of b is the square root of a times b. The square root of a divided by the square root of b is the same thing as the square root of a over b. Those are important. Okay? So let's go through another example. And this is our last example in this section.
Can you go about this to the top of like that?
Yes. You're welcome. So let's simplify the following expressions. Let's simplify the following expressions. Here we have the quantity 3 plus the square root of negative 2 quantity squared. We have that quantity squared. So that means we multiply what times what? No, we do not multiply by the complex conjugate here. Remember, we multiply by the complex conjugate whenever we were dealing with quotients. Good. And this is not a quotient. Whenever you have a quantity squared, that means we do what? Multiply the quantity times itself. Very good. So that means we have 3 plus the square root of negative 2 times 3 plus the square root of negative 2. Okay? And then we use the FOIL method. Okay? So then we have our first times our first plus our outer, which is 3 times what? Good. Say it loud, though. Be confident. Times the square root of negative 2 plus our inside, which is? Good. The square root of negative 2 times 3. And then our last, which is the square root of negative 2. Good. And then we simplify where possible. Where possible. Okay? 3 times 3 is 9. And then our next term is just 3 times the square root of negative 2. It is what it is. And then we have plus 3 times the square root of negative 2. So again, this term becomes this. This term is this. Then when you multiply the last, we're going to use this first recall. We're going to use the first recall because negative 2s are real numbers. Negative 2 and negative 2 are real numbers. So we get plus the square root of negative 2 times negative 2. That's using recall 1.
Which would be 4.
I didn't hear you.
Oh, no, I was just saying that it would be
Okay.
4.
But we have to write everything before that. So we have 9. What happens with these terms here? They do not cancel because they are not opposites.
Would you combine them?
How? Oh, you raised your hand? Go ahead. Okay. Combine them. Both of you are correct. How?
Would you multiply the number in front of 3?
What does this operation say we're doing? Adding, so no multiplication.
Would it be 6 over the square root?
Where's the over coming from?
I mean,
Square root of negative 2.
6 square root of negative 2. Very good. 6 times the square root of negative 2. So this is plus 6 times the square root of negative 2. Good. This is like saying you have 3x plus 3x. That gives you 6x, but your x is the square root of negative 2. Does that make sense?
yes.
Okay. And then plus the square root of 4. Good. What's the square root of 4?
2.
2. Okay? So, this becomes,
10.
let's be careful. Hold on. Okay, so just so we're correcting this, we have the square root of -2 times -2, which is really the square root of -2 squared. So this becomes 9 plus 6 square root of -2, all of that minus 2. 9 minus 2 is what?
7.
7. Good. So 9 minus 2 gives us 7 plus 6 the square root of -2. And that's our final answer. No, it's not. Just kidding. Because you're taking the square root of a negative. So what happens? We just did this rule where the square root of -a is equal to I times the square root of a.
Is it gonna be 6i times
It is. So this is going to be 7 plus 6i square root of 2. Very good. Very good. What questions do you have?
Did you get the I from the -2? Like the negative.
So taking this step
Yes.
instead of a writing 2, you get the square root of -1 times the square root of 2. So this becomes I square root of 2. So here, so zooming in on this portion, we have 6 square root of -2 is equal to 6 square root of -1 times 2. That's 6 times the square root of -1 times the square root of 2. The square root of -1 we know is I. So this is 6i square root of 2. What other questions do you have? Okay, so let's look at another example. We have the square root of 18 over the square root of -2. The square root of 18 over the square root of -2. Okay, so we can write this as the square root of 18 can be rewritten as, or factored as, a perfect square times a number. 9 times 2, very good. And then the square root of -2 we just said was what? Well, not equals there. We just said the square root of -2 is the same thing as what? Very good. I square root of 2. So then what we have here, notice that our numerator becomes what? If you simplify the numerator, that becomes what? Very good. 3 square root of 2, because the square root of 9 is 3. That's where that came from. Over I square root of 2, what happens? That's very good. The square root of 2 cancels out. They can't play no more. So this gives us 3 over I.
Which is just 3.
No, we have to do some work because now we have a complex number in the denominator, so we have to multiply by the complex conjugate. Very good. So this is 3 over I times what? Negative I. Very good. Over negative I. Remember, you have to put it in the form of 1. You're great at identifying the complex conjugate. Make sure you multiply by the complex conjugate in the form of 1. That's important. Okay? So then we multiply. 3 times negative I is negative 3I. Multiply your denominators, you get negative I squared. So this becomes negative 3I over negative times, what's I squared? Negative 1, good. So this becomes negative 3I over 1, which is what? Negative 3i. Good. That's our final answer. That's our final answer.